Okay, so picking up where we left off, we're going to take some expressions. We're going to use these properties up here, and these are mostly activities to prepare you for other things we're going to do in the next section. So what you're doing here is it says write each expression as a sum or difference of logarithm. So it's kind of like what we just did. There's a few differences though. So the first thing is, if you have a log of a fraction, what do? You write it as the difference of the logs. Okay, so what you do is you just write the log of the top. And be sure you put that base 4 there. Don't be lazy about that base. It's got to be there. It doesn't change. Okay, if you leave it off and just say log y, then the problem's changed. That's log 10. So that's all you do on that problem is that. We're going to kind of start simple, and then we're going to build up to some that have got a little bit more work in it. Okay? So you got to know what to do with the properties. And we're just using these 3 properties up here in this box. Okay, so you got to get this down. If you have a log of a base of something to a power, you're allowed to bring that exponent down in front. That's the first thing you want to do on this problem, is just bring this thing down in front. So take the 6, bring it down in front, and write that as 6 times the log base 7 of x. Now that's all you can do with that problem. Again, we're going to kind of prepare for the problems that are going to have several steps in it. Okay? All right, so at this stage, know that a log of product is the sum of logs. Log of a difference is difference of logs. And then how to apply that exponent. Okay? All right, now they're going to get a little more advanced as we go through this. So what you want to see on this problem is you have a product. You have e to the negative x times y. So how do you break up a log of a product? Sum, good. You write the sum of 2 logs. So you got to do this in a certain order too. So your first step is you're going to say ln e to the negative x plus ln of y. Okay, that's what the property above says that we do. Well, but we're not done. What can we do to that exponent? You can bring it down in front. Okay, so you want to get used to doing that. Okay, so we bring that down. So that comes down, and now you're going to have negative x times ln of e plus ln of y. Now that's using all the properties right there. You break it up into a sum of logs, then you bring the exponent down. However, you're going to encounter this a lot. You either want to memorize this or you want to know how to figure it out. Okay? ln is really a log base e. So if you're going to figure out what the answer to that is, what do? You just say e to what power is equal to e. What is that? It's 1. Okay, so the ln of e is 1. Because, and the reason it's 1 is because e to the first is equal to e. So this thing right here gets replaced with 1. So you would get negative x times 1 plus ln y, or that's just equal to negative x plus ln y. That's as far as you can take that. Okay, so you're expanding these things out. When it says write expand or write as sums or differences of logs, your answer typically will have several logs in it. So we start off with an expression with 1 log and we kind of expand it out. Okay? All right, the next one we have log of x. I'm just putting the times in there to emphasize what's going on the problem. Okay, so we have this. All right, so it's a log of a product. So what do? You do the sum of the 2 logs, right? So the 2 things that are being multiplied are this and this. So what you want to do right now is go ahead and just break it up into 2 logs being added. So you do this. You say ln of x plus ln of square root of 1 plus x squared. Okay, but we're not done. Here's one of the things you got to remember. And we've reviewed this enough. So you guys need to remember, like if you had the square root of 2, that's the same thing as 2 to the 1/2 power. Remember that? We've reviewed that. Or if you had the square root of x, that's x to the 1/2 power. That's what square roots are. You guys remember that? Okay, you need to. So we're going to write this as ln x plus ln of 1 plus x squared to the 1/2. So that square root gets changed into a 1/2 power. Okay, there's one more thing I can do to this problem. What do you think? Very good. You bring that thing down in front. Good. Okay. So we're going to have ln of x this exponent, anytime you have a log of something to a power, the power comes down in front. So you're going to say 1/2 ln of 1 plus x squared, and then that's as far as you can take that. You can't go any further. Okay, you cannot do this. A lot of times students think you can go ln 1 plus ln x squared. You can't. You can't break a log of a sum up into the sum of the two like that. So that doesn't work. So you're done. Okay, you guys follow the logic on that? By just applying those properties in a certain way is what we're going to do. Now we're going to get into these is probably about as big as I'll ask you to do, these examples right here. Okay, so let's do these. All right, what you see on number 5 is you have a log of a fraction. So how do you break a log of a fraction up into two logs? You subtract, right. You're using the property ln m minus ln n. So we start this by saying log of the top minus log of the bottom, which is square root of cube root of x minus 2 like that. Okay, so that's easy enough. That's the property. I'm not done. What do you think I do? That last problem I did something with the square root.
The cube root can be raised to a third power.
Right, a 1/3 power. Good. Okay, so you need to remember that, like if you had a third root of 2, that's really 2 to the 1/3 power. Okay, a fourth root is a 1/4 power and so forth. So what you want to do is you want to write this as log x squared minus 1 minus log of x minus 2 to the 1/3. Then what? Bring it down. There you go. Good. Okay, so you're going to say log of x squared minus 1 minus, and then bring that down in front, so you have 1/3 log of x minus 2 like that. And that's it. That's where you stop. Can't go any further than that. So what you really want to do is your answer needs to have more than one log, and you can't have any exponents on that. You just have the log of something. Okay, and that's how you know you're done. All right, this one's a little different. So let's say that you have the log base 2 of something to the 3rd power. The something is this thing that's in parentheses. What are you allowed to do with the exponent in this case? Bring it down. So you start by bringing it down like that. Okay. So when we start this, we have to actually start this way, because you have the log of something to a power. So your first step is to write 3 times log base 2 of 2x minus 3 over x plus 1, like that. But there's more. What do you do if it's a log of a fraction, like it is? You subtract, exactly. So what you have to do is you've got to bring down the 3, and then you need to have a bracket, because that 3 is going to be multiplied by the result of what we're going to do here. Okay, so we have a log of a fraction. We know we change that into subtraction, the log of the numerator. So we say log base 2 of 2x minus 3 minus log base 2 of x plus 1, and then that's your answer to your problem. Okay, can't go any further. And the thing is, you have a log, you have more than one log, and you don't have any exponents. So you want to make sure that you don't have any exponents, because if you did, you could bring them down in front of the logarithm, and that's as far as you can go. Okay, these are exercises to help you learn your properties, that's all. Yeah?
Can you write the 3 in front of the logs instead of...
Yes, you're just saying, can we distribute? Yeah, you can do that too. So you could write your answer as 3 log base 2 of 2x minus 3 minus 3 log base 2 of x plus 1. You don't have to, but it's correct. Okay, so you can distribute it if you want to like that. Okay, now we're going to do this in reverse next to kind of finish this up. So what I'm doing on these problems is I'm giving you more than one log, and the idea is the answer of these problems is just going to have a log. Okay, just a log of something. Okay, you want to compact that. You're kind of doing these properties in reverse. So one of the things that you want to start, you have to start these problems this way. Anytime you have a number in front of a log and you're putting it back together, well, you can undo that property. Remember how we've been bringing the exponent down? Well, what do? You can bring it up and write it as an exponent. So we can write this as log base A of x to the second plus log base a of y to the 1/4, like that. So you have to start that way, right? Okay, now how do I put these together? I add the two, I write it as a product, right? If you have a sum of two logs, you write this like this. So you say log base a of x to the second times y to the 1/4, like that, and you're done. So we've accomplished what you want to accomplish. The thing that you always want to have on your answer is this. Okay, you want to have just one log, and you don't want to have anything in front of that log. No number in front of the log. That's how you know you're done. Okay, so that's what you're doing. Okay. All right, now what we have on this one is you have two logs subtracted. So how do you put it into one log? Log of a fraction, good. So you go like this. You just write one log. Whatever comes first is the numerator. Okay, whoops, I'm not ready to do that yet. I wasn't paying attention. Let me explain why I'm not ready to do that. I mean, you're eventually going to do that. Come on, stop this. All right, let me backtrack on this a little bit. What do you do with that 2? Got to do that first. You have to. What in the world did I just do? Okay, bugs. Okay, so what we got here is when I write this like this. We got log, just bring this down and write that as log x squared plus 3x plus 2 minus log of x plus 1 to the second. Now see, it's important that you do that because you cannot put these logs together unless there's nothing in front of the logs. Because the property says log m over n equals log m minus log n. Okay, the property clearly says you can't have anything in front of the logs. So now you're ready to put them together as a log of a fraction, but only now. So we say log of x to the second plus 3x plus 2 over x plus 1 to the second, like that. So the difference of two logs becomes the product, or not the product, the quotient of the two logs, like that. Okay? All right, did you get the gist of how that's going? All I'm trying to do is teach you how to do these properties forwards and backwards. Okay? All right, now let's, if you look at this next page, I'm going to do a couple of them that are a little bit bigger. And what we're going to do on these then is I'll let you finish up with a couple, try to do a couple of them on your own. I'm not going to do much simplifying with these things. I'm mainly just trying to get you to get these things into one log. So number 3, how do you start? There's only one thing you can do. You bring the numbers in front of the log to the exponents. You have to do that if you're going to put the logs together. So that comes up. That comes up. That's the first thing that you got to look for. So you're going to have the log of x to the third plus 1 to the 1/3 power plus the log of x to the second plus 1 to the 1/2 power, right? Now, how do you put these two logs in one log? You multiply, okay? Remember, if you do the sum of two logs, that's the same as the log of the product. So you're going to say log of x to the third plus 1 to the 1/3 times x squared plus 1 to the 1/2. You're just taking this and reversing it, so that would be your answer your problem. Okay? All right, that makes sense? Okay? So you got to go about doing those things in that way. Again, your goal is to have one log and nothing in front of the log. That's how you know you're done. Okay? All right, now this has got 3 logs, and there's 2 ways to do this. The first thing I'm going to do on this is, let's just look at what I just highlighted. You have 2 logs that are added. So how do you put them together into one log? Multiply. Very good. See, there's nothing in front of the logs, so you can go ahead and do that. If there was a number in front of the log, you would bring it up. So you're going to write this like this. You're going to write this as ln of x over x minus 1 times x plus 1 over x to the second, like that. Those are now put together. Then you're going to bring this log down like this. Now this one can get into some pretty messy algebra, so that's what we're going to do is after we put this together, we're going to have to do a little bit of algebra at the side. Okay? So now what do I have? I have two logs and I have a difference. So what do? Log of a fraction, exactly. Okay? So let's go ahead and just write it like this. Let's write ln, make yourself a fraction, and really that ln should be like directly in front, kind of like that. So the numerator is going to be x over x minus 1, x plus 1 over x squared, over x squared minus 1, like that. Now that is a mess. That we have accomplished the goal of putting this together, but I want to see if you guys see a couple of things on this. So what I'm going to do is we are going to simplify this thing right here just kind of at the side. Okay? So watch carefully. This would be the part of the problem that students might struggle a little bit with. So what I want you to write down at the side somewhere is just write down the numerator, x over x minus 1, times x plus 1 over x squared, and you're really dividing that by x squared minus 1. Okay? Most of you took Math 55. You learned how to do division and multiplication of algebraic expressions. You did that quite a bit in that class. So how do you divide by a fraction anyway? You multiply by the reciprocal. So let's write this as, let's bring this down, that's x over x minus 1 times x plus 1 over x to the second times 1 over x squared minus 1. Okay? Now, you think of anything else I could do? You can factor. There is factoring going on. Yeah, good. Okay, there's two things actually. You can factor that, okay, and notice you have an x and an x squared, so those things will reduce. So this is kind of what you would do in an intermediate algebra class, is you reduce algebraic fractions. So what we want to do, I'm going to write this like this. Some of this you could do in your head, I wouldn't care. I'm going to write this as x squared is x times x. And then you got to remember how to factor this. This is called the difference of two squares. So you go x times x to get x squared, 1 times 1 to get 1, and then you guys remember how the signs go? Plus minus, okay. You're going to have to review stuff like that. That's the factoring of a difference of two squares. Now let's cancel everything that cancels. So x plus 1 cancels, one of the x's cancels, and then let's write what we're left with. So it looks like the numerator just has a 1 left over. The denominator has an x, and it has two factors of x minus 1. So couldn't you just write that as x minus 1 to the second? Okay, so now we're going to write our final answer like this. We're going to say ln of 1 over x times x minus 1 to the second. Okay, I'd expect you to be able to do algebra at that level. You need to. If you're going to get to higher math, you need to be able to handle algebra of that type. And that's mostly intermediate algebra stuff. Okay? All right, you guys see what I did at the side on that, okay? Okay, that's good. Okay. So let's go ahead and do, I'll give you guys a little time to do 1 and 2. Work on that for a few minutes and see what we get. It looks kind of to me like number 1, you're going to have some factoring that you want to do on that. It's going to be similar to the last problem. It's not as complicated as the last problem, but you want to think about seeing if you do have any factoring on that, because I think you do. Okay, well, I'm going to go ahead and run through them. Let's see if we're on the right track. Okay, how did you put number 1 together? Fraction, right. Okay, so you got this property here. So you're just going to say log of x to the second minus 5x minus 14 over x squared minus 4. Okay, now you got some factoring. I think it goes on, and you might have cancellation. Did you have cancellation? Okay, that's what I thought. So you should have factored the numerator as x and x, 7 times 2 to get 14 with a minus 7 and plus 2. Then the denominator is the difference of two squares, so you should have done x times x, 2 times 2 with a plus and minus, with one of those canceling out. And then you're ready to write your answer. That'll be as far as you can go, so you would get log of x minus 7 over x minus 2 like that. Okay? All right, and the next one, how did you start the next one? Yeah, anytime you have a number in front of a log, you have to start that way. You can't start putting the logs together until you do that. So your first step would be log base a of x to the 1/2 plus log base a of y to the 4th, and then minus log base a of x to the 3rd. So you have to start that way. Now what you want to probably do on this is go ahead and put these together. You can do this all in one step in your head if you want to. So you put these together by doing what? By multiplying. Okay, so you would say log base a of x to the 1/2 times y to the 4th. Okay, that's the sum of two logs is the log of the product. Then I've got one more thing here to do here. So how do you put it together to close it off? You put it in a fraction, right? Okay, so you say for your final answer, log base a of x to the 1/2 y to the 4th all over x to the 3rd like that. Okay, that's what you should have got. Okay, so that's kind of what you get into this section mainly is the properties of the logarithm.